they're still very conventional, looking at, what happens to, for example, Tom Bohne if I train him, pure endurance, right? Like that's interesting. What happens to a weightlifter? But what if you combine them, the interference effect? This was really something that still to this day intrigued me a lot.
Yeah, so much to discover. I mean, we've discovered so much. We have such advanced technologies, like ways of doing research, and still so many questions unanswered. Let me run by you a quick theory of mine. I've never heard it quite put like this, and I think you're just the person to say, "Hey, you're onto something, Massimo," or "I don't know so much." I'm thinking of the scientific process, like in our field, sports science, for example. I think of 3 big domains.
Yeah.
Like one domain for me is mechanism. Then one is epidemiology, like what do we see in broad data sets. And then one is RCTs, like experiments, controlled experiments. And I feel like there's knowledge out there, there's research pertaining to mechanisms. And then sometimes this gets blown up. There's a mechanism, and because this is on the cellular or molecular level, this must apply because this is the basis for everything.
Yeah.
And then obviously epidemiology, and we know correlation doesn't equal causation, blah, 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 and experiments. And all of these 3 domains have their pros and cons. But I think there's very, very, very little where we have converging evidence in 2 or maybe all 3 of these domains. So what do I mean specifically? There's mechanistic research out there. For example, the interference effect, right? That's a wonderful example. We know the AMPK, pathway versus mTOR, and there is this interference thing on the molecular level, and therefore endurance and strength don't go along. And then there come experiments, there comes more epidemiological data, and we see, it's maybe not as clear cut. So, okay, my actual question to you is, sometimes mechanism can mislead us.